welcome back again. And now what we're going to do is we're going to try some more complex graphs. Complex graphs of radical expressions. Well, to be perfectly honest with you, they aren't more complex. It's just that until you've tried a few of these, this problem that I'm about to put up on the board here is a bit more complex if you're not used to it. The more you get used to this, the more you're going to see a definite pattern with respect to the math model. Remember that the math model for a radical expression is y equals a times x minus h plus k. This means a lot to us. It really does a lot for us when we write down the equation. So if we write down the equation I'm going to ask you to graph right now is y equals 2 times x minus 3 minus 4. So you can see here that what I'm doing is I am including a, h, and k. This is as complex as it gets. It's really not all that horrible as if you take your time and do it the way that I'm about to show you. It's going to make your life easy. The first thing you want to do is you want to define your domain. Okay? The domain is defined by taking the x minus 3 and making it greater than or equal to 0. And to solve this, you add 3 to both sides, and you get x is greater than or equal to 3. So what we do is we define our domain as all of the values on the interval from 3 to positive infinity. So this is the domain for this function. The next thing we should do is we should also, while we're at it, define the range. Because a is positive, what's going to happen is we're going to go from our k value to positive infinity. The other thing we should note here is that a is equal to 2, h is equal to positive 3. So notice that if this is x minus that, then h is positive 3, and then k is negative 4. The reason this is an important step right here is to note them is because we're going to use the 3 and 4 to start our vertex, or to start our graph. The vertex x and y coordinates are at h and k, the 3 and the negative 4. This 3 is the number that we need to start our table of values. So first thing you want to do is you want to define your domain and range and your vertex so you know where you're going to be starting from. So okay, we've got all that. Now we can start. So let's start with our table of values. Okay. So our table of values should be like this. Well, let me give a little bit more room because this number is going to get a little bit more complicated. Like that. Okay? Now, what we did was we said that we're going to start x at 3, and we know that y is going to be negative 4, so that's going to be our starting value, 3, negative 4. Then what we want to do is we want to add 1 to this number, we want to add 4 to it, and we want to add 9 to it, so that when we plug them into the square root, we get a nice clean square root. Okay? We don't want to get a square root of 5 because we don't know what that is. We want to get a square root of 1, a square root of 4, a square root of 9, because those we can plug in and get a normal number out. Okay, so if we're going to add 1 to 3, we get 4. If we add 4 to 3, we get 7. And if we add 9 to 3, we get 12. And when we plug those in, what's going to happen is, in this first one, when we put the 3 in, we get the square root of 3 minus 3, which is 0. and then we subtract 4, and that's what gives us our minus 4. So if we put 4 in, what we're going to do is we're going to get 2 times the square root of 1 minus 4. So it'll be 2 minus 4, which is negative 2. So keep in mind that our x value is 4, but our output value is negative 2. If we put in 7, we get 2 times the square root of 4 minus 4. So that's why we're doing it. We're doing this to be smart. So it's 2 times the square root of 4 is 2. 2 times 2 is 4 minus 4 is 0. So at 7, we're at 0. And then if we put in 12, we get 2 times the square root of 9 minus 4. So we get 2 times 3 is 6, minus 4 is 2. So at 12, we're at 2. Nice. So those are the values that we want to graph. Okay? So by doing it in this order, it's going to make your life much easier. So all you have to do now is give yourself some coordinates. 1, 2, 3, 1, 2, 3, 4. At 3, negative 4, we have our h and k. And then we want to go to 4, negative 2, 4, negative 2. And then at 7, 4, 5, 6, 7, we're at 0. And then 8, 9, 10, 11, 12, we're at 2. And your graph goes like that. And that's all you have to do. Just get close enough for horseshoes, right? Just get close enough. And that's how you graph a more complex number, just by following the procedure, keeping your eye on the ball, taking your time. I know that I make it look easy, but with practice and by doing it in the right order, you're going to make it look easy too. So let's go to B. I'm going to try one. I'm going to show you one more, and we have y equals 3 times the square root of x plus 1. Oops. So it's going to be 3x plus 1. I'm going to write it like this so that you get used to understanding the fact that when you see it to the 1/2 power, that's really what your mind should be doing this. Like that. And then we want to pick out our domain. Our domain is going to be taking the x plus 1 and setting it greater than or equal to 0. If we subtract 1 from both sides, we get x is greater than or equal to 1. So we write that as negative 1, that's a 1, to positive infinity. And then our range, because a is positive 3, we'll go from k, which is positive 1, to positive infinity, like that. And then our vertex will be at negative 1, 1. The negative 1 and the 1, the h and the k that you use for your domain and your range. Okay? Now that we have that, we can go to our table of values. And it was, what was it? It was 3 times the square root of x plus 1 plus 1. And we want to know our x and y. We know that we're going to start at negative 1. We're going to add 1 to that to 0. We're going to add 4 to get 3. And we're going to add 9 to get 8. So it'll be 3 times 0 plus 1 will be 1. So negative 1, 1 is our starting value. If we put 3 square root of 1 would be 3 plus 1 is 4. So at 0 we'll be at 4. If we put in 3 will give us the square root of 2, which would be, let's see here. I'm sorry, the square root of 4. So it'd be 3 times the square root of 4 is 2. It'd be 6 plus 1 is 7. And if we put in 8, we get 9. So we get 3 times the square root of 9 plus 1 would be 3 times 3 is 9 plus 1 is 10. So we get 3 and 7 and 8 and 10, like that. And once we get those values, we can start our graph. We go negative 1, 1, plot a point. At 0, we're at 4. At 3, we're at 7. And at 8, 4, 5, 6, 7, 8, we're at 10. So 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We should be about here. And we're going to do something like that. Pretty close. Okay, so notice, I'm just getting close enough. You don't have to go crazy and be perfect every time. But you can get close enough so that, you hit your dots. All right, so that's how you graph. More complex. Follow the steps and you'll be fine. It'll be easy and you'll be done. Thank you.